Hello, today we're going to look at the Solver Participation Project. We're going to learn how to use Solver and we're going to learn how to specify constraints for Solver. The first thing that you need to do is download the provided data file. To do that, go to the Participation Project page, click on Data Files. Go ahead and open the folder and then choose to extract it. I've got it there, and you can go ahead and double click and open the file. Once you've opened the file, you're going to want to enable editing. And let's go back and let's take a look at a PowerPoint presentation that talks about the Solver add-in. There are a couple of things you need to know that are a little bit different than things you may have done previously. So the Solver add-in itself provides advanced features for solving complex problems. It really is GoalSeek on steroids. GoalSeek allows you to solve for one variable at a time, whereas this allows you to modify multiple variable cells at the same time. You can set constraints of max and min values on those variable cells, and you can use different solving methods to find the best values. Now, the Solver add-in, if you're using an older version, for example, Office 2016, you would go to File, Options, and select Add-ins. If you're not doing that, the best thing that I found to do is go to Excel, under Search, look for Add-ins, click on it, and it brings up this dialog box, and you can choose to add the Solver add-in. That's going to be the easiest thing for you. And then when you do that, you can then go to Data and you can see the Solver right over here. So that takes care of that portion of it. Let's flip back and take a look at what we need to do to begin to work on this. To use Solver, we want the Solver add-in to explore different mining scenarios on the forecast sheet. We want to find the growth rate that results in 164,200,572 tons of coal mined in 2019 in cell G6. The reason we've picked that number is, as you'll see, that was the amount mined on the first data point, the first year that we have recorded of West Virginia coal mining, and that was the highest number that we hit. And we'd like to see what kind of increase it would take to get back to that. So we're going to have Solver change the cell value of cell B4 until it locates the correct value, and we're going to use the simplex LP solving method. Okay, so let me go here. We're going to go to Forecasts, and we're going to click on cell G16. What we want to happen is go to Data and click Solver. We would like G16 to have a value of 164,200,572. And we're going to make that happen by changing this cell right here. And we are going to make that happen by the simplex LP solving method. Click Solve, and we accept the solution, and you can see that it has to be a 32% increase for us to get from this number to this number. Straightforward enough. Now let's take a look at the next request. It's a little bit more complex. Coal prices do vary by region. If you take a look, you can see that on the prices, the prices do vary a little bit depending on the region. Some are a little higher, some are a little lower. So what we want to do is find out where we can mine coal to minimize the total value of coal in I-16. We're going to have Solver change the values of G6 through G15 until it locates the correct values, and we're going to use the simplex LP solving method. So basically we want the smallest number possible in I-16. We're going to manipulate G6 through G15, in other words, that's the cell we're going to change, and we're going to set a constraint that G16 has to equal that amount. So let's take a look. So we're going to go here to I-16. We're going to go back to Data and over to Solver. and we are going to set the objective for I-16 to be the smallest it can. We're going to do that by changing, let's see, I believe it's these cells right here. Let's double check. It's always good to check your work. Yeah, G6 through G15. And finally, we're going to add the constraint that this cell has to equal 164,200,572. Now, what's going to happen is when you do that, when you solve for it, it's going to blow everything out but the lowest price coal. You'll see here in just a second. And there it did. All the coal was mined for the lowest price. Boom. And there you can see how that works out. So the next step is we'd like to not eliminate all the coal mining across the state except for one region. So what we want to do is we want to ensure that additional mining takes place in the region with the lowest coal prices while using all the existing mine capacity. We'd like to minimize the total value of coal in I-16, and so we're going to make this a little bit more complicated for Solver. What we're going to do is have Solver change the values of G6 through G15 until it locates the correct values. And he tells you down here how to achieve that. Because this is a little bit more complex problem, I'll probably switch back and forth a couple of times to make sure I get everything correct. So, let's go. We want to go back to Solver, and we want I-16 to be at the minimum value. We want to change the same stuff that we changed before. We want to have the same amount, I believe, of coal. Let's see, yeah, G16. Now we have to set an additional constraint that G6 through G15 has to be greater than or equal to the values of the previous year. So what we want to do is add another constraint that these, or excuse me, that this has to be greater than or equal to this. We'll add that constraint. Click OK. And then, let's see. We need to use the simplex LP method. Hit solve. And you can see they're all at least the same. This one includes a little bit more than it was previously, so we've met the constraint. And that's how you would do the Solver participation project problem. If you have any questions, let your instructor know. Thank you.